Steam start for those.
So hope like after lunch आप लोग ready हैं next session के लिए? ठीक है, नहीं भी है तो अगली session है. So we have co-founder and co-founder and CEO of Robotics Technologies, one of the company like who is I have seen in Jamshedpur, one of the best in this robotics and technology, who are doing real-time solutions, who are solving many problems. Just they'll say about themselves what work they are doing. We will be having a visit also after that, after this short session. So he'll be saying about strategic R&D in robotics and entrepreneurship. So we learned about the robotics, okay? We learned about the industrial things, how to connect with it. Now he'll be connecting all the stuffs like strategic R&D and different IoT devices or robotics in one way, like how to go up with the entrepreneurship. Because designing a thing or designing a robot doesn't come to an end. Not a robot, any project or anything. So what is the end part of it? Someone who can use it, someone who can sell it, someone to connect with the customers, consumers. Then only the cycle will be completed. Okay. Otherwise, बना के खिलौना साइड में पटक दो, it it is worthless. Okay. So I think you'll be getting a lot of knowledge, a lot of interest in this topic, in this lecture. So please welcome. Uh, we have Rohit Anand sir, and along with him his colleague for this lecture. And then please welcome him like with a round of applause. A very practical type of session. So be energetic. You will enjoy. I can bet. Okay. On.
Hello, am I audible? So I've been told that you have been there for robotics, IoT, and automation. This is a workshop based on robotics, IoT, and automation. And we are a startup that works in that field, in a similar field. And we develop robotic solutions and robotic platforms. So to start with, I have another 2.5 hours with you where I need most of your time on a dual mode interaction instead of me telling and you listening the whole stuff. Okay. So before starting on the visits and starting the interaction, I would like to give you a brief introduction on what we are doing and why India need much more strategic R&D and a lot of entrepreneurs to become a real global power. So once I'm into the entrepreneurship, I read a lot of book. So I'm going to quote it from another book. That's The Great Tech Game by Anirudh Suri. And some of my experience that I have gained in last 2 or 3 years. So basically, the country that holds technology is the country that shapes the future and its destiny. So technology is one of the great resource to basically go ahead and become a global power. We can see this by some of the examples, like let's say during the period of British era, when Britishers were ruling us, they have destroyed a lot of our manufacturing sectors. We could see that because we don't have electricity at that point of time, and they were having that. Due to that, all our commercial manufacturing was destroyed, which we were doing past in the past post like before the British era, which we were doing very fantastically. After that, we could see during the World War II, the Allied powers only won due to the nuclear bombs that they have built. Little boy, yeah, little boy and fat man. So, with these two examples, we could say that technology is something that builds the future. So then, why, as a startup, where as a startup we came in into the scenario? So as we know that the world is moving at a very fast speed, and we can see that Industry 4.0 that we are talking right now is at our doorsteps. And what do you think? So you all have must visited or seen our industry. So what do you think from a country perspective? Where do we stand at a door of Industry 4.0, 3.0, 2.0? Anyone have a least idea like where along with the whole? So we have, if we see the whole Indian scenario and the Indian subcontext of the manufacturing. So where do we stand? Are we at Industry 3.0 or we at Industry 2.0? Sure. So what do you think? What's the percentage? So, my friend, basically talking about Industry 4.0. So, India manufacturing power. So, basically, India is a manufacturing based labor intensive economy. So, India is not at still 4.0. India has started implementing 4.0, but it's still very far. It will take them another 3 to 5 years to implement that. Talking about India, there is a very big sector that has been dominated, and one of the biggest employer is the MSME, medium and micro small scale industries. So some industries are even not in industry 2.0. They are very much labor intensive as of now. Okay. So you could say we are not somewhere near even 3.0. So it's the next step that we are looking at 3.0. Then the 4.0 would be there. And people have even right now started talking about 5.0. And what's 5.0 with the changing semiconductor industry? So we can say right now the semiconductor industry, they have broken the Moore's law. So which was the basic building block of a semiconductor industry, that we could package the double amount of conductor in some specific time. So that, and coming to and coming to the other part, which is the quantum computing. So we could say that in coming days, how we think about computers would be changing a lot. We could see a very fast rapid scale development in these big companies, their ecosystems and other things. So again, we have to work a lot. As a company, we need more. As a country, we need core technology. Best in core technology, we need to build our core technology. Then only we could go. So moving to our, I was talking about 5.0. So once we have a good amount of quantum computing in the process, we have a good amount of processing power, which we are seeing with NVIDIA wants to use and everything for AI only. We could say next decade would be a decade of robots. Here we could say that most of the robots that we will be having can do versatile work. Even we could see right now across globes. So 5.0 will be all about robots. And the country, those who would be handling the core technology of these robotics element, would be leading the global scenario. What are these core technologies? It's the AI to power the brain, the actuation systems to power the motions and other things. Moving towards the mechanics to power the bionics, then electronics to connect the metaphysical world, and moving towards the material science to give the robot the right touch, the right feel that you look. So these would be the things that would be controlling, and these are the key elements that we should focus at. Moving towards the next topic. So basically, how we do it, I have given you a lot of things. So we as a startup, how we implement it at our end. So this can be done with the what I would be doing is I would be drafting a scenario where what robots are doing as of today and how we are changing the scenario, and then what we are doing to basically do implement the changes. So right now, if anyone has visited any automotive company or seen a manipulator, there are 2 to 3 common things. The first one is the work cell or the work environment is pretty much self-defined. It's have a very strong coded or a hard coded set of rules that it need to do and a repetitive task. So what we are doing, what we are just removing that well-defined environment, and we are giving a chance to robot to work in a versatile environment, or you could say a rudiment environment with a lot of you could say a lot of things that are not common in the typical work cell, or you could say a lot of disturbance. So how do we do it? It's a very critical thing. So we are working on different kind of sensors. We are developing our own subsystems. And to power the robots, we have designed an ecosystem known as Orion systems. So all our bots are designed on those systems. So basically, once we were making this company, we have built our three basic analogies. What is a robot? How we typically differentiate between them, and what's the key element to make a robot. Okay, so to talk about robotics, robotics is an implementation or a union of four specific field of engineering, that is mechanical engineering, electronics, computer science, and material science. So once these four concepts of engineering come together, integrate together, form a good balance between them, we create a robot. This was the first analogy that we have created. The second analogy that my team works at is we have divided all the robots that we see into three broad categories. The first one is the manipulators, what you could see, what automotive industry heavily employs. The second one is the mobile robots. So this is the new thing that is coming that would be implemented in 4.0 all across the industries. And the third one is hybrid systems. It can be a combination of a mobile robot and a manipulator. It can be a combination of any kind of, you could say, process automation that you could think. So these we broadly classified into hybrid systems. So this is the second analogy. And the third analogy that we have built is to scale this. So basically, we are not making a single project. It's okay, we have done, we have received something, and that is done. For a startup, economics is something that we look at. So we give it a scale. So how we give it a scale is we work on platforms. So what we do is we create platform based on our Orion systems. And that platform is used to develop the end application. With these three analogies and the platform that we build and the way we operate, that gives us an edge in developing a fast platform cycle. So what we do is within a 6 to 8 month, we come with a new platform that goes to testing. We do a test of minimum 5,000 to 7,000 working hours. That goes till where somewhere around 10,000 working hours. Once that is done, we call the platform into a production level. So what this does is 6 months a platform and 15 days a application based on the platform. So this gives us a lot of fast development cycle, which help us to reach our customer as fast as possible and work on multiple applications. So instead of creating a robot from a scratch, we replicate the platform and we create the application from the scratch, and then we plan to replicate it and scale it as fast as possible. So this is how we as a company operate, and we as a company scale our system so that we could change the world. So all of you are from the field of robotics. So you might be common with words such as ROS, MATLAB, EDA, CAD, etc., etc. So anyone, what is ROS? What is MATLAB? What does it do? What? Why we use MATLAB? Coding purpose. Okay. Or anything else? Simulations. Nice. So one of the major application of MATLAB is designing the control algorithms. A lot of people use Simulink and other things to design the control algorithm. Okay. Then there is EDA, which is electronic design automation, and there is CAD. So you have multiple software except ROS and MATLAB. These are the softwares, and other one are the tools that we use to make it. So they all have one thing in common: do not originate from India. So these are the core building blocks of a robot. And if we don't have these softwares which are designed in India, we cannot become the superpower that we are looking at. So strategic R&D is very much required in collaboration with academia and industry, so that we could have a well-defined path where we want to go and we want to develop our ecosystem in such a way that we could scale the manufacturing that we are looking at We could bring in the core technologies that we are looking at, and we don't have to rely on any other third country. That is something that will really enable us to develop systems or products that are widely acceptable. If we grow across industry, we can see Russian tech, we can see German tech, we can see Italian tech, US tech, and Chinese tech even as well. But Indian tech is not available. Indian tech is not available in manufacturing. Defense, it's changing a lot. Agriculture, again, the manufacturers are here, but design is not being done here. Same goes for automobile in some cases. So this is the thing that Indian tech is not acceptable in India. So to change that, we again as academia, as you people working in PhDs or doing your PhDs, doing your MTech, doing your BTech, should focus yourself with a plan of the year that you are in to create a highly scalable product in association with a company that while coming out you shouldn't look for a job, because we need entrepreneurs, we need people who could create great products so that we could change the way we are operating as of now. Moving towards the next topic is how basically a person who is looking to develop something of their own in the field of robotics or in any field can get the help of today's ecosystem that is available in the country as of now. So there are a lot of things that we hear round the day, round the clock in entrepreneurship. We are getting this much of funding. People are moving from one step to another phase. There are startups like Zomato, Ola, then there comes Swiggy. So what they have in common? Anyone? Come on, these are real names that you use. You might be using a Zomato app weekly or daily, a Ola app weekly or daily. What they have in common, other than they are unicorns? They are all service-based company. So we don't have a good product-based company in India as of now. So let's change a way that we look at, and from a service-based and or a labor-intensive country, we have to become a tech-intensive situation where basically people like you and me, or let's say people like students who are right now in schools and planning to come to college, can have a different perspective, different approach. Real time projects is something that I would be focusing. So basically, everyone has to submit a project or two into their, let's say, final year classes or next year, or let's say, minor projects, major projects. So everyone does that. So can we plan something like that along with the teachers? Sir, आप लोग का guidance रहेगा तो it would be much more comfortable for them. You could develop a solution for a company, for a startup. If you could reach to us, a startup like us, we have real time problems that are scalable. In fact, we have problems that we could also employ your student, your faculty, or we could help them to get the right market. So we have a very scalable problems. Every company has, not only us, each and every startup, each and every company has that kind of problem. So if you could have a pipeline in your where we can come in as a product enabler or as an idea enabler and help to fund your students to basically create the product at the end of their project, and they could come up with the product, and if we will be providing you the trial or we will be providing you the right condition for a trial, and if that is successful, what we could do is we could help you to scale it. So at the end, once you are up, you would be having a product with you. What that will help you is gaining the right knowledge to go into the industry and start working. And secondly, what that will help you is during your job interview or during the interview that you will be facing, you can tell that this is something that I have built. I have my own patents. I have my own research papers. I have my own things that I could scale. So you would be much more confident at that point of time. So this is need to be done. Now I would be again going to a story, and I'll tell you why I'm not talking about the tech. Is my team has planned something at the office. As sir has told that we won't be moving there. So there we would be talking a lot about tech. There would be talking a lot about robotics. There you would be seeing the real robots that we have made. There you would be seeing the prototypes that we are working out. There you will be learning how basically we are integrating different technologies to work in conjugation with each other so that a robot can come up. So moving to the story that I have been talking to about, there is a small country named Israel, in the Middle East. So it's a small country. It's a very small country, even smaller than I could say the state of Jharkhand. And what's the main businesses? Anyone know?
Defense, defense, robotics, R&D.
Automation and so how do they operate? So it's a very small country. It's not big as us. So how do they operate? They have agriculture, they have defense, they have nano materials, they have space tech. Anyone? So why a small country like them have these core technologies and why we don't have?
They more focus on research and development.
Again, true, but we also focus. So every year we have a specific budget on research and development that typically goes in. We as a country also have the budget. So their main business is to outsource their tech to a big country like us. For example, Google Maps. So Google Maps was not developed by Google. Google Maps was not, you could say, developed or ideated in US. It was developed by a Israeli undergrad team. And then they have scaled it. So after a while, Google purchased it and they have scaled it. So one of the biggest example. The second example, we all have heard about drip irrigation. So where did it come from? Again, Israel. It's a multi-billion dollar company. So the third example that I'm again going to give you is everyone has right now heard about that there is some kind of spyware software that has been running on some of the critical people or eminent people of India phones that has been running on the phones of some of the eminent people of India. What's that? Pegasus. So again, a software developed there, scaled globally across different countries. So there is a main business model, and how they do it. So basically, to get their engineering degree for the student working in the Israeli colleges, they have to make a product. They have to take the problem statement in second or third year, develop it over the course of time, and then there comes the people like there are incubators, there are people who basically have the right connects. Okay, they come in as the accelerator and they pitch in there and they scale the product. So that is something that we need as a country. Our country is so much big that our products can go and scale inside here only. We don't have to look outside anywhere. anywhere. We don't have to look anywhere outside. So there is this area. So now moving towards, we have talked about countries, technologies. Now let's come to robotics, IoT, and automation. So what is IoT? Anyone have a brief knowledge of IoT? Hmm?
जोर से कोई दिक्कत नहीं। वर्कशॉप
Anyone?
इंटरैक्टिव होगा तो
IoT,
हमको भी मजा आएगा।
IoT
बोलिए।
with the internet. Okay. Automation. What is automation? Without any rudimented idea as well. Problem नहीं है. Basic ideas. So I've told you our analogies robots के बहुत basic analogies हमने design किए.
Increase the human intervention.
Please.
The automation is basically we try to remove as much human interference between the working of devices so that the devices can interconnect and work on their own. We don't have to direct them or don't have to automation, yeah, sir.
Automation.
Yes, sir. So we have to remove as much human interference as we can so that the devices can work on their own.
Okay. चलो nice. I'll tell you. So automation is just, let's say आपको एक जगह से दूसरा जगह जाना है, let's say from point A to point B you have to go. It's a repetitive task. So industries are very big. They have a lot of tasks. So they employ people to do that task only. So सामान को let's say point A से लेना है and they have to drop it on point B. Industries keep people to do that work. And automation just automate that. Okay. And IoT comes where we connect these sort of, you could say, automation or devices to get the physical parameter into a cloud. That's the IoT. So once automation and IoT are linked, what can we do? There are a lot of products that we could develop with simple automation and simple IoT techniques. Starting from applications that can be used in regular households to the application that could even go in the field of defense, or maybe a space tech, or maybe in the field of robotics. So robots are something that go in different sectors, starting from industries to agriculture to defense to tech, anywhere you can think of. So there are specific sectors. So simple automation, simple automation and IoT can help you to create products that could go anywhere. So to have a basic understanding of that is must. Then working on hands on. So कितना भी आप पढ़ लोगे, कितना भी आपका theoretical knowledge होगा, until unless you don't have hands on any of the system, it's very hard to go much more into the details. So that is something that I want to tell you. Moving towards the other topic. So automation की हम जब बात कर रहे हैं, there are two things that we known as is PLC. Everyone might have heard about, because you are from the side of automation. And we have a other thing that is called embedded systems. So anyone embedded systems के बारे में किसी ने सुना है? That is there, but what's the difference between, so embedded system is a combination of hardware and software, okay, to perform some specific task. Okay, it's very good. Now moving towards the another part of my question. What's the difference between a PLC and a difference between an embedded system? And why we have embedded system, then why do we need PLC? And if we have PLCs, why do we need embedded systems? Anyone? So basically, PLCs are embedded systems designed to perform in hazardous environment. This is the basic difference. And if we have a very good knowledge of embedded systems, so embedded system can come in different forms, starting from basic $1 chip to a $100 embedded system, or maybe a uh, microcontroller. Okay, then you could design your own system over it, so that won't be a problem. But to have a very critical knowledge of embedded systems, you could directly deploy to a hazardous environment. What that will give you is that will give you a hands-on on how you could start your journey in the field of automation, IoT, and robotics. So there is something that you don't need a specific hardware, a specific product to start on. It's just you need the right mindset to start on. So with this, let us now talk about some of the real-time application that we are solving across industries and across, I could tell you, sectors, different sectors. So we have been also trying to get into Indian Army, Indian defense services, sell our products there, sell our robots there. We have been trying to sell our robots in the field of dry bulk handling, which is like company like Vedanta, Tata Steel, Sailworks, and we have been pitching to something like Bairak, where we could get our robots into the field of agriculture. Then coming to health tech, so we have met Devi Shetty, one of the most renowned, you could say, doctor in India, who is specialized into the cardiology. So we have met people across sector, and we are trying to push our product everywhere. Okay, so I've told you the basic how we develop the system that could be scaled to different sectors, but how we are getting through it. So how we are designing the system so that the same system can go in industry, the same system can go to defense, the same systems can go to health tech, and the same system can go to agriculture. So how we are doing that? So I told you embedded systems and PLC, very basic definition and very basic that if you have an understanding, you could go. So what we do is we have a standalone systems that we have named ORAN systems. So it is the main core that connects each and every part of our systems. Once we deploy there, we have specific mission control algorithms that goes in it. And we take the customer feedback that what exactly they need. Once we have done that, we save that you could say we save that algorithm in such a way that it could be scaled up and scaled down as and when required. So let's say we have done, our robot has performed in somewhere in the state of Karnataka, in some city. We have designed the system in such a way that I could pull down those codes sitting in my lab somewhere in Jamshedpur and deploying the same code into another system, deploying the machine learning, enabling the machine learning data from that robot and getting it done, sending it the whole algorithm that they have developed, whole structures that they have developed into the another robot or into the centralized system, and make them work, make them know the amount of data that this robot has generated into those systems. So machine learning is something that comes in and that help us to scale a lot once we talk about robotics. So this is another area where you people could also look in how basically machine learning affects automation, IoT, and even you would say the field of robotics. Typically into the end application development, typically into the field of, I could tell you, field of industry automation, field of defense, field of agriculture. So agriculture is the next big thing that is coming in. Because if we say we would be growing at the scale that we are growing right now, but the agriculture land won't be growing. And the resources that we have, that is going to be scarce and scarce every day. So there is again an area where a lot of innovation is required, where a lot of automation is required, where a lot of critical infrastructure is required to basically grow. So let's have some interaction with you people. So how many of you have made a real robot, done a real automation, or used a IoT to get some data from a device to anywhere in the cloud?
You can raise your hands किन्होंने अभी तक robots वगैरह बनाए हैं ऐसे आज
Two people? Anyone else? Three. Three people. Okay. So what you have used? So robots बनाते समय what's were the basic hardware if you could tell us you have used or basic software that you have used? Anyone? Three of you. कोई भी.
I have used it to basically I have used the motor, it's the motor. Okay, and for designing the different component of the motor assets of the recharger, to not and then created in 3D print. One software for 3D printing and printing or like three cameras. This was happened.
You.
I can also simulate on in MATLAB or in some file. I don't know. बीटेक में हमने ड्रोन बनाया एक्चुअल फ्लाइट कंट्रोलर पे यूज किया बाकी प्लेट के लिए ड्रोन के लिए बेसिक ड्रोन मॉडल एप्लीकेशन हम लोग सर्विलेंस के लिए यूज करते हैं.
Perfect. Third one.
बेसिकली मैंने एक सिंपल प्रोजेक्ट बनाया था मतलब एकेडमी के कंपटीशन के लिए एक रोबोट था जो मतलब डिफाइंड पाथ पे चलता था और अगर कोई बॉक्स मिले तो उसको मतलब पिक एंड प्लेस करने के
It's a line follow kind of.
यस सर एंड आई यूज ओनली IR सेंसर एंड अल्ट्रा.
So the robots that you have made are good. These are good robots, but these are very basic robots. Okay. So anyone who have made, I have been to other sessions as well. So anyone who has made a robot or made a system that typically works over a embedded or a embedded system. Typically, a embedded system can also run a OS. Okay, so you need to have one brain for it. They have used ROS, robotic operating system. So what I have asked them is, let's say remove the ROS from the industry or from the environment of robotics. How you could develop it? So ROS पे किसी ने काम किया कभी भी? So ROS is something that has become the general norm as of now. And what you have told, the softwares and other things, they have a very single common thing or have not been originated from here. So we need a very strong base again. And try to develop systems, try to develop core technologies is one of the key things that students you should be focusing on. That people who are studying should be focusing on because they have a very good ecosystem. They have a very good access to the people who have knowledge. They could access to industry. They could access to NGOs. They could access to a lot of government funds, which we as a company can't. There are a lot of government funds that could be accessed by you, starting from a basic of Nidhi Prayas, then Nidhi EIR, then there is a specific grant for electronics. TST have a lot of schemes. BIRARC has a lot of scheme. MITI has a lot of scheme. So you could have access to those schemes. You could ask your college to draft a proposal for you. you could get the sign and you could post a proposal to these ministries, and you could have access to the fund where you could develop real good projects. And the fund is also huge. I'm not talking about, so this fund start the things that I have told you starts from 6 lakhs of rupees and goes somewhere even to a 2 or 3 crore rupees. So that's the level of project that you could make at. So people here in the bureaucracy is also ready to give the funds. It's just you have to push a little bit harder to get that. So that's all from my side, sir. So any questions from your side? Anyone who want to interact? Any doubts? Anything?
Anyone?
Any open source software for simulation? Really power.
So what kind of simulation you are looking at? So there are two type. Yeah, there are two type of simulations. So ROS is open source. ROS can also be simulated. You could also simulate in Unity engine. Yeah. So that's why I told you what kind of simulation you are looking at. So there are simulation software such as ANSYS and other things to do the mechanical simulation. Whereas for robotics, we talk about environmental simulation. So basically, you need to have a specific kind of environment. You need to have. You could also reach NVIDIA ISAC. It's one of the best in industry, but you need to have a good computing power. Computing power is must for simulations, so that can be accessed.
Any other queries? कोई भी कुछ भी पूछ सकते हो. Nothing?
Anyone?
I think they are more attractive to going for a visit.
No problem. So we would be moving from here to the visit.
So
Sir,
before that,
please.
we just thank you, sir, for giving the precious time.
Sure,
And
sir.
I'd like to call upon Dr. Jayan Kumar, sir, who's coordinator of this event, for giving a small token of gesture to you, sir. Sir. थोड़ा सा side. So I'd like to call upon Saket sir also stage. Okay. Thank you, sir. Love you and your insights in this, and we'll love to move forward for the visits.
One more thing I like to add. One more thing I like to add. If anyone want to reach us, okay, for any of your query or any of your thing, please reach us out. Okay, we are there to help you. We will be guiding you. Okay, and if possible, we could see how we could solve your problem as well. Thank you.
Thank you.